For this video we're going to complete example 3, and this is going to be a very long problem, a very tedious one to solve. It starts off by saying that a helicopter drops off 2 passengers at 2 different locations, and this whole question is already been drawn in a diagram for you just to make it a bit easier. It says first it flies on a bearing of 80 degrees. So we can see that here. Here's our bearing of 80 degrees. This is our starting point O. And travels for 126 kilometers to deliver person A to their destination. So we've marked where person A is delivered. This is person A here. Second, it travels on a bearing of 60 degrees. Here's the next bearing for 12 kilometers to deliver person B. So this is where the helicopter basically finishes its trip. But after it finishes its trip, it wants to get back to the starting point, and this question is all about finding the shortest route back to its starting point. I'll actually show you what it looks like, this shortest route. Basically, the shortest route is going to go from point B back to point O in a straight line. So I'll do this in, I'm actually going to just make this line a bit thicker for you to look at. So there's our green straight line. That's the path that the helicopter is going to take back, because that's going to be the shortest path. The shortest path is always a direct straight line. And question A and B are asking you, first of all, to find the bearing that the helicopter needs to take, and second of all, it's asking how many kilometers the helicopter will need to travel. So I've created a new page with our diagram. The reason I've done this is because we need a lot of room to put all our working out down. Okay, so you'll notice that there are 2 straight paths that the helicopter takes, from O to A and from A to B. And we're going to turn these 2 straight paths into 2 right-angled triangles. So for the path from O to A, I'm going to draw dotted lines to turn this into a right-angled triangle like so, and the same for the path from A to B. It's a little difficult with the 12 kilometers in the way there. Okay, now for each of these triangles there is a horizontal component and a vertical component. So this is the horizontal component of the triangle using O and A, and here is our vertical component coming up. For our second smaller triangle, we have our horizontal and our vertical component. Now, to distinguish between each horizontal and vertical component, let's call this H1, V1, and for the other triangle, H2, V2. So we'll start by focusing on the larger triangle. We'll call it triangle 1. We really need to find an angle, and the best angle to find is right here, which is 10 degrees, since 10 degrees plus 80 degrees makes 90 degrees. Now V1 is going to be our opposite, H1 is going to be adjacent to the 10 degrees, and the 126 kilometers is going to be our hypotenuse. So let's focus on finding V1 first. So we're going to, in order to find V1, we're going to focus on the opposite V1, and we're going to focus on the hypotenuse to work it out. Bringing up SOHCAHTOA, since we've got our opposite and hypotenuse, we're using the first 3 letters of our acronym. So we're using sine. And its sine of 10 degrees will be opposite over hypotenuse, which is V1 over 126. V1 therefore will equal 126 times sine of 10. Bringing our calculator up, 126 times sine of 10 equals 21.879, so on. So let's round this to 3 decimal places. I think it's very important with these questions to have as many decimals as you can, so we'll pick 3, and that'll round to 21.880. kilometers. So that's our vertical component. Now we need to find H1, and in order to find that, we need to focus on the adjacent H1 and the hypotenuse 126. And adjacent and hypotenuse means we're using the middle part of our acronym, or cos. So cos of 10 is going to be adjacent over hypotenuse, which is H1 over 126. H1 will equal 126 times cos 10 this time. Bringing up our calculator, clear, 126 times cos 10 equals, to 3 decimal places, we'll go 124.086 kilometers. So that's given us our vertical and horizontal component of triangle 1, the larger triangle. Now the smaller triangle is a bit crammed, so I'm just going to redraw it down here and draw it a bit bigger. Let's mark it. So for this one, it's got a 12-kilometer hypotenuse, and we've got V2 and H2. We need to figure out the angle down here, and because the angle up here is 60 and the other part of the angle will be such that they add up to 90, that tells me that this is a 30-degree angle. Alright, so we know that V2 is our opposite, H2 is our adjacent, and the 12 kilometers is our hypotenuse. So we'll focus on the opposite and the hypotenuse first and see what we get there. So opposite and the hypotenuse is sine. Sine of 30 degrees equals opposite over hypotenuse. So V2 over 12. Therefore V2 must be 12 times sine 30. Bringing up our calculator, clear, 12 times sine 30 gives us 6. That's nice. We get a nice whole number, 6 kilometers. And we also need to now find H2 by focusing on the adjacent and hypotenuse this time, or cos. So cos of 30 is going to be adjacent over hypotenuse, or H2 over 12. So H2 will be 12 times cos 30. What do we get? 12 times cos 30, giving us 10.392 kilometers this time. So I've cut out all the working out and just given us what's important. I needed a lot more room to do our working out. And this time we're going to really only focus on our horizontal and vertical components, and we're going to focus on this green line. And the green line represents the shortest route the helicopter can take to get back to base. We're going to find the bearing of this route, and we're also going to find the distance it would take for the helicopter to get back. So let's make this green line into its own right-angled triangle. Let's make it all in green so that we can see it over the other writing. It's a nice right-angled triangle. It also has a vertical and a horizontal component. Now, we actually have enough information to figure out what this vertical and horizontal component equal. And that is because if we look at H1, H1 is this distance here. This is H1. And H2, the second horizontal distance, is this distance here. So our horizontal distance for the green triangle can be taken by adding those up. So H is H1 plus H2, which is 124.086 plus 10.392. What do we get when we add those up? I'm just going to use my own personal calculator here. And I get 134.478 kilometers. Let's write this in green. So our horizontal component is 134.478 kilometers. Let's look at our vertical component. It works the same way. It can be split into two parts. This is our V1 component, and this is our V2 component here. So we can find V by adding up our two vertical components, V1 being 21.880 and V2 being 6. So for this one we get 27.880 kilometers, and that is what our green V value will be, 27.880 kilometers. Now once again our screen is getting a bit messy, so we need to redraw this triangle somewhere else down here, a nice right angled triangle, and we've found out that our vertical component is 27.88, we won't worry about the 0, and our horizontal component is 134.478 kilometers. And we want to find the length of the hypotenuse, which will give us the distance it will take for the helicopter to go back from point B down to point A. The other thing we need is our bearing, and if I bring up my compass, the helicopter is at point B traveling to point O. So we need to have the compass where the helicopter is at point B. Now I'm going to move again to another screen to give us some room and space to work this out. Let's focus on the easier part of the question. We're going to find X. This is actually part B that we're finding, the distance that the helicopter needs to travel. And this is easier because it's just Pythagoras Theorem. X squared equals 134.478 squared plus 27.88 squared. Now I've already worked this out on a calculator and it came up with 18,861.62688. So I left as many decimals as I could here. And then X is found by finding the square root of that. 8. This came out to 137.3 kilometers. I believe it was to one decimal place. Yes, here we go. 137.3 kilometers. There's our solution to question B. Okay, now for the more challenging question, we need to find the bearing. So we need to do question A. Funnily enough, question A is a harder question. And the best way to find the bearing is to find this angle here. Let's call it theta. And once we got that angle, we can just add it to 180 degrees. It's 180 degrees to south, and then we need to add theta. How are we going to do that? Well, we can see this is our opposite. It's opposite theta, and this is our adjacent. So we're just going to use opposite and adjacent, which for SOHCAHTOA is the last three letters, the T-O-A that we're using. We're using tan. So tan of theta, tan theta is opposite over adjacent, so 134.478 over 27.88, and theta will be tan inverse of this fraction. So bringing up our calculator, we're going to go second function tan bracket 134.478 divide 27.88, and then close our brackets, equals, to the nearest degree, that's 78 degrees. And to find our bearing, all we need to do is add on the 180 to this, giving us 258 degrees as our bearing. And we'll put that up here, and that will conclude a very long example, example 3.